Hello, everyone. My name is Vadim, and today, with my colleague Silvio, we're going to present you how we actually manage cluster lifecycle at Uber. Yesterday, I was thinking why it's actually interesting for you, right? Because Uber have a really big scale, and not many companies run on this scale. But I think the idea is that we first of all, of course, want to share you what we're doing there and kind of show you our infrastructure. And also, we want to tell you that some problems which you can face can be super simple for you to solve. But if you go on Uber scale, it's actually really hard. And we go through the different ideas. We have a different problems there, and we want to share what we figure out. Let's start and understand what this cluster lifecycle is. So imagine you want to run different workloads, stateless, stateful, right? You need Kubernetes cluster where you're going to run all of them. And your cluster, during its life, go different stages. First, it starts to be turn up, then it's active, and during active phase, you can change your cluster setup differently, right? Maybe you want to apply new controllers, or you want to change node type which you run there. And if your cluster is not really lucky, it can be decommissioned at the end. I want to tell you about one story. Imagine we have a developer. Let's give him a name also Vadim. I like this name. And Vadim really want to run new batch workloads at Uber because he thinks it's really cool and it will give him really good promo, so why not? And then what happened next, right? He needs to create cluster for testing, for example. Only one cluster to just test his ideas and show the boss that, oh, looks, actually it's really working very well. And many, many years ago at Uber, how it looked like, I think it's around 1 year ago, actually, Vadim will go to the 15 or maybe even more steps. First, he needs to get capacity for his cluster, right? Because it's should be a lot of nodes and stuff. Then he will deploy control planes there. He needs to take care of how it's going to run, where it's going to run. Then he needs to apply configuration on his cluster. Of course, somewhere, it doesn't work well. And he needs to repeat it again and again. And it's super painful, but at the end, after several weeks, he'll get his cluster, actually, where everything's going to run. But Vadim is super unhappy, because imagine to try some stuff, it requires you 2 or 3 weeks of manual work. And it's actually really, really not good, I would say. So let me tell you also a bit about our scale, right? Because I told you that Uber scale is super big. So we have around 100 plus clusters in production, which actually handle user workloads there. We run this cluster across 15 plus different zones, different regions. And our clusters actually really easy to configure. So you can do different shapes, different configuration for your host, different configuration for your controllers. So it's super dynamic. And of course, there is around more than 1,000 engineers who wants to run and use these clusters. And of course, they want to change everything, what they even possible. And another important stuff about Uber clusters, we actually use pretty big clusters. Our nodes count for one cluster from 5K to 7K, for example. So it's really, really big. And it's where our team actually came up. Because if you, small company maybe, you can just create a new cluster in Google Cloud or something. But at Uber, you can see we run it across on-prem data centers and also cloud, different cloud providers. And our team at Uber, we located between users who run their operators and foundation. Foundation is team whom we go and say, oh, please us give some more host because we need to run our workloads. So our team is compute, and what we do in Uber, we responsible for control plane, right? For all native controllers which we run, native components which we run there, how we deploy them, how we scale them. Also, we're responsible how we apply cluster configurations, right? Because you want to configure it, again, a lot of different parts, and we're responsible to maintain this. And at the end, we're also responsible to run different controllers. Because our clusters run stateless, batch, we're also now going to run stateful workloads there. And we have a lot of custom things how to do it properly on our big number scale. So where we start before we do all our incredible work? Our cluster provisioning requires you to go through the 15 manual steps as a developer. And it doesn't sound really cool, right? Also, it gives you a lot of weeks of work because it's really, really hard. You don't even have single source of truth when you, as a developer, as a cluster owner, can see what's goal state going to be for your cluster. And honestly, it's kind of sad. And remember this Vadim who wants to create new batch cluster to just try stuff? We have a lot of Vadims like this who is not happy, but our team tried to make their life much easier and try to make them a lot happier. So after we see all these problems, we came up with ideas how we actually can solve all of this, right? First of all, what we really need to do, we need to create cluster configurations and make it more better for people so they can easily change some different settings for their own cluster. But we need to be really careful because our team is responsible to maintain this configuration and apply. So we really need to be careful how much flexibility we provide to our users. Also, we need to create the automation cluster turn-up process, right? So you want to have the same experience in Google Cloud. Just push one button, and your cluster is done in like several minutes, maybe, even maybe hours. Then we need to allow people change their cluster when it's actually active. So imagine you have a cluster with 5K nodes. It's running workloads. It's serve traffic. But you still want to do some changes, right? You still want to change hosts which are running there. You want to still change controllers which you run on top. And at the end, again, if your cluster is not super lucky, and it's supposed to be decommissioned, we also want to automate this process for people. So they also push one button and cluster disconnected from production, and it doesn't serve any workloads, and we can return capacity back. So let's go with me to this journey, and I will tell you how we do it step by step. As I told you before, we need first provide people configurations for their cluster and how they can work with this. I think the main point here, we need to define what cluster is a tuber, right? What dimension it exists and what actually important. So we have a lot of different configurations for our clusters, but I think the main thing is what of type of workloads you're going to run, because it's actually mapped to our cluster type, we call it. So you can run stateless workload, you can run batch workload, and many, many workloads there. Yeah, super. After this, our cluster have different topology. It can be zonal clusters, regional, global. So it's actually another thing which you want to configure when you create cluster. And another main thing for us is cluster phase. As I told you, you go from the turn-up phase to decommission phase. And through the steps, different cluster phase enable different point of our stack. For example, if your cluster is not fully active, you don't want to get observability. You don't want to get alerts, right, if something doesn't work, because it's still turn-up process. So we have this all dimension, and then we thinking how we can model our configuration for our clusters, right? First thing which we find out is that we actually can split it in two parts. Static parts, it's cluster configuration which with your cluster through its life cycle. So when you create new cluster, as a cluster owner, you want to provide name of the cluster, zone or region where it's going to run, also type which is workloads which you're going to serve. And this configuration don't change at all during cluster life cycle, right? Because it's there with cluster for all time. And actually, this type of configuration is super simple for us because we don't really need to care how we're going to change it in productions for you. This is one part. And there is, of course, second part, which is dynamic configuration, which you want to change during cluster lifecycle a lot. And we need to figure out how to merge them all together and be able to create this cluster configuration for more than 200 clusters which we actually run. And what we figure out, right, template is really good. You can template a lot of stuff, and why we don't use it. And I think also another thing which we figure out is you don't really want to configure each cluster. It's not needed, right? Because, for example, you run stateless workloads, and usually configuration for your cluster for stateless workloads is the same all the time. So what if we tell people, OK, you can configure your cluster type kind of template what's going to run there, but you don't really want to configure anything for cluster specifically. Of course, if you want, you can, but most of the time, it's not really needed. So then we provide a layer. We use Starlark for this. It's kind of Python-like language, which kind of get your static config, our dynamic config, and merge them together. And at the end, it provides you, for each of cluster which you run in production, or like staging, etc., it provides you all configuration which needs to be applied or used. Another important stuff here is actually when we do all this stuff, we already have 100 clusters in production which are already running there, right? We cannot just say, oh, let's move everything to new configuration type and just, it will work. No, because of course it's not going to work. So we carefully need to support old way how you define cluster and how do you configure them a new way. So we also provide a layer which do cast between old type configuration and new type configuration. But at the end, we makes Vadim from another universe a bit happy that now he actually can configure what he wants to run and how he wants to run this stuff.
OK, so now when we solve the configuration problem, let's have a look into how we actually use that configuration to also automate the cluster provisioning at scale. So the project we went with is the Kubernetes native, which means we have a declarative model, and that is going to let us define the cluster in form of the CRD. So we are going to have the cluster object as our input to the automation, and then we have an operator which is going to reconcile that state. This operator is then also going to sync with Git, and it's going to talk to external APIs to create this cluster. So basically, this is how I made the shift from a manual process to an automated one. We can now describe the cluster, and then the system is going to make it real. Here we can see an example of this cluster object. So that's going to be an input to the automation, and it's how we define the goal state. In the spec, we can see some of the things that the user can define. For example, what should be the zone of this cluster? Should it be a stateless or a batch cluster, maybe? Should it be a staging or a production cluster, and so on? And then in the status, this is what the operator is going to be updating. We have the conditions, and it's going to let us know which steps of the cluster provisioning were done. At the end, we can also have the phase that's going to tell us if this cluster is still in the process of being created, or is it done. So it's only going to be this thing that the users have to define, and everything else is going to be handled by our automation. Now let's take a deeper look in how our operator actually works. So as we said, we have a cluster object as an input, and then we have our operator, which we call the Kubernetes cluster orchestrator, and it's basically a bunch of different controllers which work together to make this cluster. Main control that we have is the cluster controller, and it also works as the workload engine to execute all the steps needed to make this cluster. We are going to hear more about this in a bit.
Oh, nobody want to show what we did.
Should be employed.
Yeah, I think we need some help here.
Yeah.
Yeah, maybe it's going to be, I'm going to tell you what we're going to do there.
So it just stopped working.
could just reconnect it again. Oh, it works. Super. Thank you. A bit stressed, but it's okay.
Yeah. OK, so where were we? Yeah, as I was saying, we have the cluster controller as the main controller, and then we also have some other controllers to be able to delegate some of the more complex steps. So, for example, to make etcd for this cluster, we have a etcd controller to also validate this cluster, and we also have validation controller. Here we can see a simplified view of all the steps involved in creating the cluster. So at the top, we can see some of the infra provisioning steps. Then we have to get the host for our cluster. Then we have to set up the control plane, set up also the Uber services, some configuration, and then at the end, we do validation. So some of these steps have to be done in parallel. Some of them also depend on each other. And also for some of them, we might want to check before or after the step if it can be executed. So the question here we had is, how do we actually make this happen in the reconciliation loop? Had to write all of this to not make it like a huge mess. So for that, we decided to model it as a graph, and we came up with our own framework, which lets us do that. As a result, we now have like an easy way to write these steps and also extend our automation to also support more of the workflows. Yeah, so one of the most challenging parts that we had to do is integration with all the Uber internal systems that have to be here involved. So for example, our automation has to talk to many different deployment engines. We also have our own way of how we manage the capacity, how we generate the certificates. Also, we have to talk to different APIs to make the cluster. So since all of these systems are external to the operator itself and can be not reliable at this scale, here we had to apply some patterns for the resilient integrations, such as site-dependent calls, rate limits, retries, cooldowns, and so on. So yeah, this was really important as the failures, as I said, at this scale can be normal, and we also needed to design for that.
OK, after some stress, we can go another fun part. It's we now, for Vadim, right, what we can do. We can give him access how to configure his cluster, to run his workloads, and also now we can build his cluster super easily. But there is next big problem. What if he wants to change something during cluster serving production workloads? For example, it's already not staging ready production. His new batch workloads running there. It's running across 100 clusters, or like 50 clusters, still a lot. And he thinks like, oh, let's actually deploy a new controller to all of these 50 clusters to, I don't know, somehow do node maintenance for this, because it's required, right? And there is a problem, how to do it actually safely. Because as you remember, we now can generate for him 200 configurations, and we can tell him only for now, yeah, you can use it, but you have to apply it manually, change your cluster manually. You can do it. But of course, it's not really working well, because it will create incidents. And then Vadim has to sit in outage Zoom with people from director level and explaining what actually happens there and why. And I don't think it's a really good idea. So you can think about this problem from different angles. You can use maybe some open source solution, like for GitOps, try to apply config from your Git on the Kubernetes cluster. But I want to tell you different perspective. So as you know, at Uber, we really think a lot about how we deploy stuff safely, how we apply configuration in a safe way. And there is this too, right? Because cluster in production, and we need to do it super safe. So for now, we have only one system, only one operator which creates your cluster. But it's not really a good way, because what if you want to change some code there, right? You just do global blast and can break everything. So idea is, let's do it a bit more safety, and let's use actually what Uber provides you to do it. Like, we have really good system when you can deploy your services. You do it like in a safe way. It can go like first tier 3, tier 2, and tier 1 environment. It can run end-to-end test and check results, and then only after this it can go to production. So we actually can apply the same logic to our orchestrator system and say, OK, we don't want only one operator run and operates, but we want to shard it and say, OK, we have one operator which will serve only dev clusters, another one which will handle staging, and final one will handle production. And then your configuration delivery problem actually can be simplified and be binary delivery problem. So let's just connect our binary for our orchestrator with configuration which needs to reapply to our clusters. In this case, after our developer wants to run their new controller or something, he can update list of controllers, just push it to the Git, and then CI/CD for orchestrator system automatically will get this change and apply to the cluster, and do it in a really safe way, because it's first go to end-to-end environment, wait end-to-end test to pass, see everything works well, and then go to staging and that in production. So at the end, we actually don't involve any third-party services. We just use what we already have and make it safe deployment there.
OK, so now when we can make clusters, and we can also change them safely over the time, the cluster is eventually going to reach the end of its lifecycle, and we're going to have to decommission this cluster. So let's take a look into how we do that and how we do it safely. So basically, for the whole decommissioning workflow, we use the same model as the provisioning. We have the CRDs for the goal state, and then we also have the controllers that are going to execute the steps. Another thing that we have to do here is also clean up all the resources that we create as part of the cluster creation. And for that, we also use the finalizers. So in this context, the finalizers are going to let us block the deletion of all the objects until all the externally created resources of these objects have been deleted first. So only after that, the operator is going to be able to delete all the objects. And we also store history of everything that happened in the status field so that we can audit it later. And now we get to the most important part for decommissioning, and that is safety. This is very important, as mistakes here can also lead to the maybe outages, some data loss, and even bring down the whole business. So to solve this, we implemented safety on the multiple layers. On the first layer, we have a cluster that has to be first approved by someone else, and we check for that by admission policies. On another layer, which happens in the operator itself, we also have a quarantine period, and that lets us have some time to be able to change our mind on if we want to stop the cluster deletion. Another thing that we do in the operator is the concurrency limits. And this is also very important, as it allows us to limit of how many clusters do we actually want to be able to delete at once. So in our case, we want to be able to delete all the clusters at once, because it would cause like big incidents, obviously. And on the third layer, we also do some rate limiting towards other systems at Uber that have to be here involved, and that lets us kind of limit some of the most destructive actions, such as removing hosts or also downscaling some of the critical services. So yeah, basically all of these layers set together, it gives us a very high confidence that our automation is going to be safe. OK, now let's take a step back and look into what we achieved here and some of the key takeaways that we have. So the impact of this work has been very significant for us. We started with the config that was hard to work with, and it's now in a much better place. It's also centralized in Git, and we have a single source of truth. We also started with a manual process of cluster provisioning and also decommissioning to a now fully automated one, and it only takes hours instead of weeks. And all of this together also allowed us to have our cluster lifecycle fully integrated with the rest of the Uber ecosystem. What are some of the key things that we learned with this? So first, integration was the hardest part, right? We didn't just have to build like a new system that's going to be isolated. We had to connect many different systems into a single automation. Second, keeping the declarative configuration in Git turned out to be a very good decision. So it also enabled us to do the GitOps, and it gave us a single source of truth. And last and third, we think it's important to store it small, so we didn't automate everything at once. We first added the support for the cluster creation, then for the reconciliation, then for the decommissioning, then for even the more cluster types, and so on. So as the requirements evolve, we think it's important to also design for that. And overall, this is how we moved from a manual cluster management to a fully automated Kubernetes native lifecycle. That would be all from us, and thank you for your time.
Thank you. If you have any questions, yeah, we will be happy to answer them. Yes, there is a microphone.
Hi. So do you also handle OS updates and Kubernetes version updates through this process?
Yes, it's not through this process. It's a bit different process. But yeah, our team also responsible for all version upgrades in our infrastructure across all this cluster. But it's go a bit in different subsystem which we use for this. Yes, but it's also automated.
OK. And so you have specific clusters where you can test.
Yes, yeah. So in general, we have like our fleet divided into dev, staging, and end-to-end production clusters. And if you want to roll out everything to production, right, we do this like steps. We first go to end-to-end, where we just apply and run our end-to-end pipelines for all our workloads, like batch, stateless, stateful. But it's really working well, and also we don't have like problem with like scale, etc. And then we go to staging and then production. So it's like fully super safety way there.
OK, yeah. Thank you.
Yeah, of course.
Hi.
Hi.
My understanding is that you basically have written from scratch what your operator actually does. What are your opinions on using, let's say, the cluster API to implement the same thing that you did? Any experiences, pro, cons, etc.?
Yeah, so the question is basically why didn't we use some existing open source solution, but do we instead build our own, right?
Yeah.
So yeah, we basically looked into using some of the open source stuff, like we looked into the cluster API. We also looked into the vCluster, but since we have many different systems at Uber that have to be involved in this cluster provisioning, it didn't really match like to how these solutions work, right? So they have like their own CRDs and so on, and it didn't really fit like in our requirements, basically.
OK, thanks.
Yeah, I think you need to think about Uber that we have a lot of different custom things for almost for everything, right? Because when it was created, open source solution doesn't exist before. But we now try to go a bit more open source world and see what we can explore here. But for this system, cluster API was really for us big thing which we look a lot and see how it's actually do a lot of stuff. So we try to get the same ideas here and integrate with all our stack. Yeah. Thank you.
Hi.
I have very similar question. Have you tried other tools, open source, like Kamaji from Classics, or I know another Ukrainian guy, he wrote kubedc, which does exactly the same which you do. And also we tried to do the similar solution. We used project stateless to deliver those add-ons. So have you tried any public solutions? What kind of challenges did you have? And are you going to open source your solution?
I think we look, of course, on different systems which already do the same work, right? Problem for us that you have to do it like for 200 clusters in production. And it's really what's make it super difficult, because for us, the main thing is do it really in safe way, because if you break something, it will be like disaster, right? People can order food and stuff. So for us, it was more easy to create our own stuff than adopt already existing things, because a lot of them not support what we want. Also, we have, again, a lot of custom stuff, for example, for release pipeline, right? It's a completely different system which already here, and it's already provides us all things which we need. So for example, why we don't use Flux CD, stuff like this to apply configuration, because we say, oh yes, we can use it, but then we have third-party service which actually goes completely different ways that our binary delivery is there. So what we just can simplify it and make, okay, we will use what we have already and just make it's already safely, so why not? So yeah, I think for us it's the main thing, do all stuff in safe way. And about open source, I think we don't have any plans about this. Yeah. We're more curious to maybe work with open source project to make it better. So this is what I believe we for sure can do. Yeah. Thank you.
Hi. You mentioned different tiers of environments, but does it mean that if I have 5,000 nodes in production, I also need 3 another clusters of different types previously to test my change?
It's actually not really, because as we have different tiers, right, of our clusters, we also have benchmark clusters. And this cluster actually when you can test your stuff on loads which you do in production. So for example, you can simulate like 5,000 nodes here. You can simulate like Uber scale, which actually hit your production cluster. And it's one of the release workflow which we do. So when you want to release new Cube version, or for example, new service which will like kind of core components, you require to go to production and see how it's going to behave on these loads. So we don't need to support 200 clusters with 5,000 nodes.
So at least one additional tier.
Kind of, yes. Yeah.
Okay, thank you.
Yeah.
Hey, thank you for the talk.
Thank you.
I have 2 questions. One is, you mentioned the foundation team or something like that. Is that the team that provides like the basic network that you will need and subnets and all of that, or is out of scope?
Sorry, could you?
So if you need to set up network, etc., do you do with this project, or is it done by your team?
Yeah, it's already in our ecosystem. So we use there is a networking team to actually handle all networking communication here, and there is a person from this team here who can ask a question if you want. But yeah, it's a foundation layer which actually gives us already networking which we can use. So we don't think about it when we build our clusters there much.
Okay, and the second question is about the configuration as code. I think you mentioned probably the tool that you use, or can you explore a little bit more that part, the way you merge the static and the dynamic?
So we at Uber, for our configuration layer, we use Terlark. It's kind of Terraform, I think. It's Python-like language, and you can do whatever you want, almost. And it's integrated with all our deployment system, which we have there a lot. And for example, also we use it to generate alerts and observability stack for you. So in this layer, it's like kind of Python code which you write, where you can program how you merge these 2 configurations together. For example, okay, I have 50 YAMLs with my cluster information, like zone, node, like type of the cluster. And then I have templates which says, okay, for stateful cluster, I need this type of controllers to run there. I need to this, I don't know, flow schema configuration and this configuration which I need to apply to the cluster. And then this Terlark, what it does, it's like consume this input and just apply it to these templates and give you different, different
Combinations.
builds for different components which it needs to use. And then you can consume it, for example, even for your service deployment. And you now, oh, if I run on stateless cluster, I need to do this. Or if I run for batch, I need to do different way. But you can consume the same source of truth to generate all of these configurations there.
Thank you.
Yeah.
Thank you for the presentation. How long did it take you to build this system, and how many teams were involved?
Yeah, I think we started like a year and a half ago. And it took, as we said, we first started with only automating the provisioning. Then we added also reconciliation of the active clusters. Then we also did the decommissioning and also the other types of the clusters. So it's still like an ongoing thing as we get like the new types of the cluster that we have to add and so on. So the core part, I would say, of the automation and also config, I think it took us like half a year, right?
I mean, POC was done, I believe, like in several months, but make it production ready, I think it's half a year. And it was only one team involved in this process. And it's around 4 engineers, 3. We're like 3 of us who work on this, I believe, core.
Okay.
So it's not much people.
So that single team had to develop all the controllers by itself, or did it receive any kind of requirements from the rest of the teams, like from the network, the security?
No, it's we don't have requirements because it's our team own cluster lifecycle, and we actually need to solve this for our customers, right? So we build our controllers and how it's going to look like, and then we just has to go to another team and say, okay, let's integrate with networking stack, let's integrate how we get host and stuff like this. So yeah, so it was pushed from our side, not from top.
All right. Thank you very much.
Yeah, thank you.
Hi, thank you. Thank you for the talk. So I wanted to ask, like, where your controllers are hosted. Like, I assume it's a different cluster where the control plane of those things are hosted, and how is it resilient?
Yeah. So as you say, like, yes, we run our controllers to build clusters, but of course we run it on separate kind of cluster where it actually operates. It's not full Kubernetes cluster because this cluster doesn't have data layer at all. It's only control layer and etcd. So it's, we have special team who provide you platform as a service. So when you can create different resources, and they provide you KSAPI, which you can use, right, to write your controllers. So we actually run on their system, so on their API server, controller manager, etcd. And it's what they do is like they globally distributed, so they don't have zone regions. It's like global clusters. But they do tiering, so they also split this global cluster in smaller parts. They have separate control plane and separate etcd there. So as we say, when we create our system, we say, okay, we will have operator which will connect to tier 0, tier 1, and tier 3 of their clusters where they actually, which they operate. So it's, we can for free get this division of our system.
And under the hood, is it still for resource provisioning? Is it still Terraform, etc.? Because like to create cluster, you will have to provision nodes first, right? So,
sorry.
Under the hood, like when your operators or controllers are scaling up the nodes, like provisioning nodes for the new cluster, is it under the hood Terraform, or like you are creating the nodes? Some internal tool is there, or like how is it?
So we have capacity team who actually kind of hide from you all this layer because we have on-prem and we operate on cloud providers. So for our user, actually, they don't really care much where they're going to run, right? Because if you run your service, you don't really want to think about this. So these systems, they kind of hide it from even from us. We know when we operate on which cloud provider, but there they just say, oh, we need 2,000 nodes, and then they say, oh, where is your financial approval for this? And then we say, okay, these people approve 2,000 nodes, and then they can provide it to us, so we can use it.
So before creating the cluster, users or the team had to take the approval first for the node provisioning and their capacity estimation? Yeah, so
before you want your cluster done, you need to go to this process and say, okay, I actually think it's going to be 5,000 nodes, and somebody needs to say, yes, okay, it's okay to spend money on this.
Got it. And for these controllers, are you guys using Kube Builder, KRO, or something?
Yeah, it's custom. It's custom solution. Yeah.
Okay, cool. Thank you. Thank you so much.
Thank you.
Hello, I have a question about the orchestrator. So you explained that cluster creation is a step of a workflow, right? Where like you start with etcd creation and eventually the end-to-end test. Inside the controller itself, like within the reconciliation loop, how do you reflect these stages and make sure that it's predictable? Is it like through the CRDs or in what ways? Maybe like some learnings from that part of the controller implementation?
Yeah, so basically that was one of the hardest part, since like when you make the object on this cluster, you still have to have a real etcd cluster somewhere else, right? So yeah, so we basically use like the periodic monitoring of like this external resource. So yeah, like it's being checked like every 10 seconds or something, like does it still exist and so on. And then if it doesn't exist on the external systems anymore, we also delete the object in that case.
And so I guess you reflect the state of truth to the CRD and use that as for the next stages. Okay, thanks.
I think we need to go, but you can still find us somewhere around to ask a question. But yeah, thank you so much.
Thank you.
Yeah, thank you.